So we'll start with the compiler design, the first unit, that is unit 1. First we will see what is mean by a compiler. So a compiler is an software that is going to translate the code which is written in one language to the other language without the meaning of the changing of the meaning of the program. It is going to translate the code which is written in one language to the another language. In this process of changing from one language to another some other language, there is no change of any program meaning. We are not going to change any meaning of the program. Just what is meant by a compiler means it only translate high level languages to the low level languages, or we can call it as the translate the code written in one language to some other language without changing the meaning of the program. So this is called as compiler. In the compiler design, the first unit we are seeing is first it is going to take the source program. Source program is nothing but it is a program which we are writing in the English language. That program it is taking as an input to the compiler. What the compiler will generate? Compiler will generate the object program. This object program is next given to the assembler. Assembler is also one of the language. It is going to translate the assembly level language to the machine language. So this assembler is responsible to transfer high level programs to the machine level programs. After the completion of the assembler, we are getting the finally the targeted program output. So this is a process how the compiler is going to be work. First the program is given to the compiler, then compiler will generate the object program. This object program will be given to the assembler, and then it is given to the assembler is generating a target program. So this is the definition of an compiler. Okay. So this is an execution process, how we are going to execute the compiler whole process. Now we will see the main topic, that is the structure of the compiler. So we are telling that the compiler is a translator to translate one language to another language. So next we will see in the translating process what is the structure of the compiler, we will see now. Okay. So next topic we are going to see is the structure of an compiler. So for any large software, it is easier to understand and implement if it is divided into small defined modules. Why we are telling that small defined modules means, if we are taking, suppose you take one large software, and it will be easier and it will be simplified when we divide that particular software into modules. So same process we are going to see in the software also. While we are generating any program, if you want to perform the testing, so complete program we cannot write the testing, we cannot perform the testing process. So what we will do, we will divide the program into small modules, and we will test the complete software by using the small modules. In the similar way, for the structure of the compiler also, it will be easier if we divide them into modules. So what is mean by the structure of compiler means, we are dividing the software into modules. Okay. So once again I will tell what is mean by the structure of compiler means, any large software, it is easier to understand and implement if it is divided into small well defined modules. So that's the reason we are implementing this structure of an compiler. So structure of compiler, in this structure of compiler we are going to divide them, or we are going to divide the compiler into different steps. So we will see what are the steps that we are going to divide in the compiler. So see here, these are the 6 steps. These are the 6 steps where we are going to write the structure of an program. I'll explain you one by one. So first see here, first one is an source program. See here, from the source program, this is an input. This is an input for any compiler. First the compiler, if you want to generate the compiler, first we need one high level program to convert them into machine language. So source program is an input. Okay, in this input we are dividing the structure of compiler into 6 phases, or we can call it as 6 steps. What are those 6 steps? First one is a lexical analyzer, second one is an syntax analyzer, third one is an semantic analyzer, fourth one is intermediate code generator, next one is a code optimizer, and the last and sixth one is the code generator. After this code generator, we are getting the target program. That is nothing but the assembly code we are getting. Okay, so these are the 6 steps that are involved in the structure of compiler. We will start with the first phase of an structure of an compiler. The first phase is lexical analysis. This is an first phase of compilation. In the structure of compiler, the first phase is a lexical analysis. What the lexical analysis will do means, it will say take the source program as an input. It will take the source code as an input to the lexical analyzer. What this lexical analyzer will do means, it will transfer the characters in the form of lexemes. So whatever we are writing in the program, the characters, those characters will be converted into meaningful lexemes. Okay, so these lexemes will be represented in the form of tokens. So it will take the input as a source program. What the lexical analyzer will give means, it will give the output as tokens. I will repeat once again what is mean by lexical analysis means. It will take the source program as an input, and it is nothing but here lexical analyzer will convert the characters in the form of lexemes. So this lexemes we are calling it as tokens. So what is the output we are getting in the lexical analysis means, output is an tokens. Okay, this is an lexical analysis. That is the first phase of compilation. We will see what is mean by the next phase, that is the second phase of compilation, that is the syntax analysis. Second phase of compilation is the syntax analysis. So what is the output of the first phase of compilation? That is tokens. These tokens will be acting as an input to the syntax analyzer. So these tokens will be acting as input to the syntax analyzer. So what this will do means, the tokens as an input, they will generate the parse tree as an output. So this token as an input, it will convert or it will generate an parsing tree. Tree is nothing but whatever the steps we are writing, those will be converted into tokens. After it is generating the tokens, they are arranged in a form of parsing tree. Tree is nothing but it is for our analysis. So to convert, we are writing the parsing tree. Tree is nothing but all the inputs we are writing at the one side, like a tree like this we are writing. Okay, I think you all know that what is mean by parsing tree. In this format we are going to write the parse tree. What the syntax analysis will do, it will take the input as an tokens from the last phase, that is previous phase, and it will generate a parse tree as an output. Okay, this is all about syntax analysis. This is a second phase of compilation. Next we will see the third phase, that is a semantic analysis. This semantic analysis is a third phase of compilation. What this we will see the fourth type of compilation, that is an intermediate code generation. This is a fourth phase of compilation. So for this last one, semantic analysis, we got the output as annotated tree syntax, we got as an output. So taking that output, what the intermediate code generator will do means the compiler generates the source code into an intermediate code. Okay, so this intermediate code is generated between the high level languages and machine level languages. So it will take this output, this will take the tree syntax as an output, and this intermediate code generator will act as an intermediate, means middle between the high level language and machine level language. So this is an intermediator. Fourth phase of compilation is an intermediator between the high level language and also an machine level language. So this is the role of an intermediate code generator. Okay, so we will see the next one, that is the fifth one of compilation is the code compilation. So what is the role of the code compilation means this is an optional phase, we can use this phase or we can also skip this phase. This is an optional phase. Okay, so it is used to improve the intermediate code so that the output of the program could run faster and take the less space. So to run our programs very fast and very easily, we have using this phase in the structure of the compiler. We have already seen the intermediate code generator. So to run fast the programs and it will take the less space between the intermediate code generator. So we are using the code optimization. The name itself, it is going to suggest code optimization, means that is nothing but we are reducing the unnecessary code in our program. See here, it removes the unnecessary lines of the code and arranges the sequence of statements in order to speed up the execution. So what are the unnecessary lines in our program? It will reduce all the statements and it will keep in one particular order for the execution to speed up the execution. If we are keeping all the unnecessary statements in our program, then what it will happen, it will take very large time to execute our program. So this what the role of the code optimization means. It will remove all the necessary lines and it will keep our program for the speeding of our execution. Okay, so we will see the last and the final phase of the compilation, that is the code generator. Code generation is the final phase of the compilation. What it will do means it will take optimized intermediate code as a output, means the previous step it will take as an input for the code generation, and what it will do means it will map it to the target machine language. So whatever the lines we have reduced, so in the last step we have reduced all the unnecessary steps in our program, that will be acting as an input to the code generator and it will produce the machine language. Okay, it translates the intermediate code into the machine code. Okay, so this is all the 6 phases of structure of compilation. Thank you.